So chapter 3 is all about functions. So we're going to start with just our basic stuff. So 3a is just about relations and functions. So what is a linear function? So when you think of linear, just a line, y equals mx plus b. But because the word function is in there, I'm going to write it f of x equals mx plus b. So the key for a linear function, it must be degree 1, and that's just going to be your line. The graph will just be a line. Quadratic function, that's degree 2. So f of x equals ax squared plus bx plus c. That's degree 2. And that's what we just finished in chapter 2. That's your parabola. So these are just kind of your introduction into functions. All right, so first of all, we say a relation is just a relation between variables, x and y, is any set of points, x, y plane, and we say that the points connect the two variables. So a relation can be expressed in a lot of different ways, and you've seen all of these ways. So first we can use an equation, or sometimes we even just say, rather than an equation, it's just a rule, a pattern, where all the x's are twice the y's, something like that. You can just say it in words. You can also see a set of points, and that might be like a table, or just, I don't even know what I'm doing here, sorry. That could be in a table, or any type of a graph. These are all ways that any of these that you have seen, those are just ways that we can express a relation. So for example, they just give you specific stuff. Here's an equation, and here's the graph that goes along with the equation. Here's an equation, there's the graph that goes along with the equations. Now, not all relations can actually be defined by an equation. So think about when you have x is greater than 0 and y is greater than 0. That's going to be the entire first quadrant. Notice how this is all shaded up here. Everything going above x and greater than in that spot there. So those are your inequalities. Then example 2 is just 13 different points just randomly put on a graph. So we just say that that's a relation. All right, so then we can get more specific about the relation. All relations, anything you see is a relation, but specific ones can be called a function. A function is just a specific relation in which no two different ordered pairs have the same x coordinate, or you can say the first component. Now, if you remember, when I talk about all x coordinates, that's the domain. So another way to think of a function, the domain cannot repeat. So that's kind of the easy way to think of. If you have to justify if something is a function or not, you're really looking at the domain. So if you're looking at a table or a set of points, you're comparing all the x coordinates. If you're looking at an equation or a graph, there's different things you do depending on which type of expression you're looking at. So the algebraic test is, suppose it's given as an equation. If you can substitute any of the x values in that result in just one y, then it's a function. But if you get multiple y's for each x, that means the x value is repeating. So going back to those two previous equation examples, for this one, anytime I plug in a value for x, I'm only going to get one y. So this we would say is a function because I can only get one x and one y for each problem I plug in. But the second one is, we just call this a relation because say that we plug 4 in for x, I'm going to get two separate y values. So think back to that graph. Like when x is 4, this point right here is for positive 2. This point down here would be for negative 2. So each value of x, I get two different y values, which is forcing the x values to repeat. So that's why we say this is not a function, because the x values repeat. Now, if you're looking at the actual graph, the geometric test, we just use the vertical line test. So we've talked about the vertical line test in the past. So come back to this graph here. If I draw a line through, if you hit 2 points at the same time, that means the x values are repeating. So if it just cuts it at one time, then we consider it to be a function. If that line goes through more than once, like over here, 2 spots, it is not a function. So here's 3 examples. In example 1, if we draw a line, if you notice, if I pass this line, if I pass this line through the graph, I'm only touching one spot at a time. So that means that this is a function. I'm only touching one point on the graph at a time. What about letter B? If I pass it through, see how I'm only touching one point at a time? That means this is also a function. But letter C, I'm touching 2 points at a time. That disqualifies it. This one is not a function. So we just label it as a relation because every single thing you ever graph is a relation, but only special relations can be labeled a function. So these first 2 are functions, but letter C is not a function. So sometimes in reading graphs, look at the graphical note here, you may encounter an open circle on a graph. So once we get into piecewise, you might see a graph that looks like this. Okay, if you see an open circle, that point is not included. So like if I draw a line through, this point here does not disqualify it from happening because this is where it actually starts. It's only if it's filled in that's included. So that means this point is not included because it's open, but this point is included. So this would be a function because they don't really overlap. And you know that arrows just go on forever. So just kind of a piece of information. So that's letter A.